Hi everybody. So this is my second video on hypothesis testing with the geometric distribution. In this video, we're going to look at critical values. We'll work through example 1 and example 2, and then we'll try an exam style question. And if you want to work along with me, you can download a copy of this PDF from my website. I'll leave a link below. So in example 1, we're told that a random variable has this distribution, geometric distribution, and a single observation is used to test that our null hypothesis is that p equals 0.2 against the alternate hypothesis that p is less than 0.2. We've been asked to use a 5% level of significance to find the critical region for this test. So we've got our geometric distribution here, where the peak is at the expected value of x. And to the side, we've got two tails, and each of these are critical regions. So we need to begin by finding which critical region we're looking at. And the way we're doing this is to find the expected value. And we know the expected value of a geometric distribution is 1 over p. And we're told that p is 0.2. So the expected value will be 5. I'll label that on the graph here. And we're given the alternate hypothesis that p is less than 0.2. And because the expected value is 1 over p, this means we're looking at the blue region. Typically, for binomial and Poisson, you would look at the region to the left because it's less than, but because it's 1 over p, we'll look at the region to the right, which is this blue region. And we're told that this is a probability of 0.05. This is our significance level. So we're trying to find the critical value here. And this separates where we accept HR to where we reject HR. So we need to find a probability of x being greater than or equal to c, which is our critical value, and this has to be less than 0.05, our significance level. And then we can see we're going to use in this equation, okay? So the probability of x being greater than or equal to c will be equal to 1 minus p, so 1 minus 0.2, to the power of x minus 1. And we know x is c. And then we know that this has to be less than a 0.5. So we have 0.8 to the power of c minus 1 must be less than the 0.05. And then to find c, we can take the natural log of both sides to the power of c minus 1 must be less than the natural log of 0.05. And then using the power rule, we can bring this power down in front. So c minus 1 times the natural log of 0.8 must be less than the natural log of 0.05. And then we can divide both sides by the natural log of 0.8. But we know this is a negative. And because we're dividing by a negative, we need to change its sign. So c minus 1 will be greater than the natural log of 0.05 over the natural log of 0.8. We can work this out, and we get c minus 1 must be greater than 13.425. So c must be greater than 14.425. But we know that c has to be an integer because this is our number of trials. So in this case, therefore, c must equal 15. So our critical region is when c is greater than or equal to 15. Okay? And then for part B, to calculate the actual significance level, well, we need to find the probability of x being greater than or equal to 15. And using this equation again, we've got 1 minus p, so 0.8, to the power of 15 minus 1. and this gives us 0.04398. So this is our actual significance level. Okay, let's try example 2. So for example 2, we're told that a random variable has this distribution, and a single observation is used to test HO where p is 0.01 against the alternate hypothesis that p is greater than 0.01. Part A, we're using a 5% level of significance to find the critical region for the test. And then for part B, we've been asked to calculate the actual significance level of the test. So again, we'll start with the expected value of x, which is 1 over 0.01, so 100. I'll label this on a distribution. And because the alternate hypothesis is that p is greater than 0.01, we're looking at this region here. And again, we've been given the significance level of 5%. So we need to find this critical value. So the probability of x being less than or equal to the critical value must be less than 0.05. And using this equation, probability of x being less than or equal to c will be 1 minus 1 minus p, so 0.99 to the power of x, which is c. And then we can substitute this into here. So 1 minus 0.99 to the power of c must be less than 0.05. And then we can move this to the right-hand side and the 0.05 to the left-hand side. So we've got 0.95 must be less than 0.99 to the power of c. And to work out c, we can take the natural log of both sides. And this must be less than the natural log of 0.99c. And using the power rule, we'll bring this down. So this must be less than c and the natural log of 0.99. So to work out c, we'll divide both sides by this, but because we're finding the natural log of a decimal, this will be negative, which means we need to change this sign. So the natural log of 0.95 divided by the natural log of 0.99 must be greater than c. So we get 5.104 must be greater than c, or c must be less than 5.104. But we know that c has to be an integer, so our critical region will be that c is less than or equal to 5. Okay? And then to find the actual significance level, we need to find the probability of x being less than or equal to 5. And using this equation again, we'll have 1 minus 0.99 to the power of 5, which gives us 0.0490 to 4 dp. Okay? Let's try one more question. So for example 3, we're given that Liam is a skilled basketball player, and he claims that the probability of making a successful free throw is 1/3. His teammate, Jake, believes that Liam is overestimating his accuracy. To test his claim, Liam takes consecutive free throws until he makes his first successful shot. For part A, we've been asked to work out the critical region at a 5% level of significance. And then for part B, to find the actual level of significance for a test. So do you want to try this question yourself? You can pause the video, and when you come back, we'll go through the solution. Okay, so the first thing we need to do is to state our hypotheses. That HO P equals 1/3. And then because Jake believes that Liam is overestimating his accuracy, H1, the alternate hypothesis, will be that p is less than 1/3. And if we define our random variable, we'll say that x is distributed geometrically with a probability of 1/3. We'll define x as the random variable, the number of free throws needed for the success. We need to work out our expected value of x, which is 1/1/3, and this is 3. We'll label this our distribution. And because our alternate hypothesis is that p is less than 1/3, we're looking at this region above the expected value. And we're told this has a probability of 0.05, our significance level. So the probability of x being greater than or equal to our critical value must be less than a 0.05. So this will be equal to 1 minus p, so 2/3 to the power of x minus 1. So 2/3 to c minus 1 must be less than 0.05. So we'll take the natural log of both sides and use the power rule to bring this down in front. So we get c minus 1 times the natural log of 2/3 will be less than the natural log of 0.05. And when we divide both sides by this, we need to change the sign because this is a negative. So we'll get c minus 1 be greater than the natural log of 0.05 over the natural log of 2/3. And when we add 1 to both sides, we'll get c must be greater than 7.3883. But we know this has to be an integer, so our critical region is that c is greater than or equal to 8. And then for part B, the actual significance will be the probability of x being greater than or equal to 8. Again, using this equation, this will be 1 minus p to the power of 7, which gives us 0.0585 to 4 dp. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and a PDF that accompanies this video from my website, mrmathmatisse.com. I'll leave a link below.